Hi, in the last example we did one example about mesh. Now I want to introduce the current source. So let me draw my circuit first of all. Here is my circuit. As you see, I have replaced my independent voltage source with an independent current source. So this symbol here, the symbol here, I'm sorry, this symbol here, okay, or we can draw it as given on the circuit, that this is a current source. Well, we call it independent current source. So when there is independent source, how we can do that? How we can use the mesh to solve? Again, we are going to define our mesh. So I'm going to define our mesh. So I take this one as a mesh I1. So again, I take a mesh I2. So if there is independent current source at outer branch, I mean, look at this one is an inner branch. This one is, I mean, from here to inner branch. Okay, so if the current source is not here, okay, but it is here, okay, it is here, so you can say I2 is equal to this current source. Okay, so you don't need to write equation for I2 you can directly take 12. Well, here there is minus because the direction we assume is opposite of the independent source. That's why I say that my I2 must be equal to minus 12 ampere. So I just need to write equation for mesh 1. So let me write how we used to do. Remember from the first example, my reference direction is this. So I just put my polarities for the resistors, right? Plus and minus, because why plus? Because the I1 is entering from here, right? So I1 is entering from here. So what is the voltage drop on these two? On these two is 2I1, correct? So what is the voltage drop on these three? Because we have I1. Let me draw it here. I1 is going from up to down, I1, and I2 is going from down to up, which is minus 12 ampere, right? So what is the voltage drop on this three? Simple, right? I1 minus minus 12 times 3. So, and here I have the 10 volt. So, by the way, just remember, before I used to show this independent voltage source like this. So sometimes you can also use this symbol for independent voltage source, right? So on this window or closed path, I can apply my Kirchhoff voltage law. Okay. So what is my what is the first polarity? I come across this minus 10, so, and plus 2I1, and here I have this one, right? Plus 3, and I have written it earlier here, 3 times I1 minus is going to become plus 12 is equal to 0. So there is one equation and there is one unknown. I can easily solve this, right? So I can say that minus 10, 2I1, 3I1 making 5I1, and plus 36 is equal to 0. Okay. So minus 10 plus 36 making plus 26, and I1 is equal to minus 26 over 5. So definitely the result is different because we have replaced it. In the first example, we have replace it in 12 volt with 12 ampere current source. So how can I make sure my result is correct? My result is correct. I can apply my Kirchhoff voltage law on any closed path, any closed path. Okay, we have actually 3 independent closed paths in this circuit, right? Okay, if I redraw it, look at this one. Okay, here. Okay, so here. So what are my closed paths on this circuit? Look at this one is a closed path. Okay. So what is the definition of a closed path? Okay, we will start from one point and we will come back this point, right? We will come back this point. I will go around and come back this point. I will not pass over on a node 2 times. Okay, look at this. You will understand it, right? So this one is also a closed path. Okay, also I have a closed path here, right? So let me give one example which is not a closed path. Look at, I start again here, I go like this, I come up down, I go back, okay? So again, I come back here. Can you see on this node for this green, right? I pass over 2 times, so this is not a closed path. So I'm going to use this one. So I have here what is 10 volt, right? So I have calculated my I1. My I1 is minus 26 over 5. So what is the voltage drop on this 2 ohm? So since I1 is calculated minus, so I must take the direction opposite, right? So this one is plus, right? 26 over 5 times this 2, right? So this is the voltage drop here. And what is the voltage drop on this 3 ohm resistor? Is, okay, we have this minus 12 here. I have here 12 ampere, right? So here the current is 12 minus 26 over 5, right? Because here, as you see, 12 ampere is coming to this node and 26 over 5 is taking this direction, so the remaining must be this. So times this is 3. This is 3. So this is the voltage drop. So let me just also put my polarities. Let me change my color again to this one. This is my polarities, and plus and minus and plus and minus. So if I write that, if I take an arbitrary direction, I use this direction, minus 10 minus 2 times, right? On this direction I take the always first polarities. Okay, you can take the exit polarities too, but I'm just using these ones, okay, these ones. Minus 2 times 26 over 5 and plus 3 times 12 minus 26 over 5, which must be equal to 0. If it is equal to 0, if this is going to give us 0, then our solution is correct. If I do my calculation, so this is minus 10. If I do this calculation, this is minus 10 over 4 and plus 20 over 4. So which gives us 0. So this part 0, this part 0, 0 is equal to 0, equal to 0, equals to 0. So my solution is definitely correct. So in these examples we learn when there is a current source, we can take it as the mesh current. If there is a mesh going over on it, okay, we can take it as a mesh. So we can do the solution. Thank you for listening. We are going to solve more examples on mesh.